A Florida lake just disappeared. Not dried up, not flooded. Gone. 12 billion gallons of water drained straight into underground caves through a single hole in the lake floor. Lake Jackson, just outside Tallahassee, a 4,000-acre lake that families have fished, boated, and built their lives around, is now cracked mud, stranded lily pads, and a gaping 28-foot sinkhole staring up at the open sky. People are literally climbing down into the hole where the lake used to be. But here is the part that nobody is talking about. The water did not just vanish. Scientists tracked it, and what they found on the other end of this underground drain is raising serious alarms about the drinking water supply for hundreds of thousands of people. Because this is not the first time this lake has disappeared. It is just happening way more often than it ever should. So why is a lake that used to vanish once every 20 years now disappearing every few years? And what is it doing to what lies beneath Florida? Thanksgiving week, 2025. The Big Bend region of Florida has already been deep in drought for months. No meaningful rainfall has reached Lake Jackson's basin in weeks. Evaporation keeps pulling water from the surface, day after day, with nothing coming back to replace it. And on the floor of the lake, in a section called Porter's Sink, the sediment plug that has held the bottom sealed for years is quietly beginning to give way. Nobody notices at first. The water drops a little lower than usual, a little lower than the week before, then a little lower still. On the evening of November 30th, Rob Diaz de Villiers, an ecology producer at WFSU Public Media, drives out to Lake Jackson at sunset. What he sees stops him cold. Water is not sitting still. It is moving, spiraling downward into Porter's Sink in a visible churning funnel, not overflowing its banks, not flooding the surrounding land, just draining, straight down, like a bathtub with the plug pulled. He photographs it in the fading light. The image is almost impossible to believe. By December 2nd, the basin floor is fully exposed. A 28-foot cavernous sinkhole stares up at the open sky where 12 billion gallons of water used to sit. A brief rainstorm arrives and partially refills the lake. For less than 2 weeks, it looks like the crisis might be over. It is not over. By January 6th, the lake drains again. By March, vegetation is already sprouting across the exposed lake bed. The bottom of a 4,000-acre lake is growing grass. By April 20th, the Tallahassee Democrat sends a photographer out to document what remains. Lake Jackson, measured at 6.2 square miles at full pool, is in their own words, almost completely dried up. A bobcat is photographed trotting across what used to be a working boat ramp. Cypress trees line the banks, their trunks marked by a pale strip of bare bark sitting 10 feet above the current ground. That pale line is not a coincidence. It is the old water line, a scar from water that no longer exists. Then on May 4th, 2 men climb down into the sinkhole itself. Matt Lisby and Michael Sayers, photographed by the Tallahassee Democrat, are standing on rocks that in any normal year would be submerged under more than 20 feet of lake water. They are not researchers, they are hunting fossils. On the floor of a lake, 12 billion gallons, swallowed by the earth in roughly 5 months. For the people who lived on these banks, who fished these waters and built their lives here, the question was not just how this happened, it was where all that water actually went. To understand how a 4,000-acre lake drains through a single hole in its own floor, you have to understand what Lake Jackson is actually sitting on. Lake Jackson is not a typical lake. It has no rivers feeding it, no streams carrying water in from the surrounding land, no outlets carrying water away. It sits inside a 42-square-mile closed basin in northern Leon County, just off Interstate 10 and 10 minutes from downtown Tallahassee. The only thing that fills it is rainfall. The only things emptying it are evaporation, seepage, and the drain plug sitting in its floor. Those plugs are the key to everything. Two natural sinkholes sit at the bottom of the lake, Lime Sink at the north end, Porter Sink at the south. Both are openings into the limestone bedrock beneath the lake floor. When sediment accumulates and seals those openings, water stays in the basin and the lake exists. When the seals break, the water has exactly one place to go: straight down. Harley Means is the state geologist of Florida with the Florida Geological Survey. He climbed into Porter Sink himself during the 1999 dry down, standing where the lake floor used to be, looking up at the open sky. He describes Lake Jackson using a simple analogy. It works like a checking account. When rainfall deposits exceed what evaporation, seepage, and the sinkhole withdraw, the balance stays positive and the lake rises. When the deposits stop, the account drains to zero. That analogy is accurate. It is also incomplete, because it does not explain what is happening beneath the surface once the drain opens. Florida sits on one of the most porous limestone formations on Earth. For millions of years, slightly acidic groundwater has been dissolving the rock from below, carving an enormous hidden network of tunnels, chambers, and underground rivers across the entire state. Florida already leads the United States in sinkhole activity. What looks like solid ground from above is, in many places, riddled with hollow space below. Lake Jackson is not resting on bedrock. It is resting on the roof of a cave system. This is the detail that changes the entire story. The water draining through Porter Sink is not disappearing. It is being swallowed into that underground network and sent somewhere specific, routed through limestone passages that no surface map can show, moving through the dark at a pace measured in fractions of a kilometer per day. In 2018, Dr. Sean McGlynn of McGlynn Laboratories poured tracer dye into Porter Sink. He wanted to know exactly where the water goes when Lake Jackson drains. Not a guess, not a theory. A direct answer, tracked through the limestone with chemistry. He waited. Days passed, then weeks. Then, 35 days later, the dye surfaced at Wakulla Spring, 30.6 kilometers to the south, roughly 19 miles. The water had traveled through the upper Florida aquifer at an average speed of 0.87 kilometers per day, winding invisibly through underground passages beneath 19 miles of pine forest, state roads, and rural flatland south of Tallahassee. Lake Jackson, in other words, is not disappearing. It is moving. Right now, beneath the ground between Tallahassee and the Gulf Coast, 12 billion gallons of lake water is making that same journey. Invisible, slow, unstoppable. The water that filled this lake on Thanksgiving morning is currently somewhere in the limestone dark, creeping south at less than a kilometer a day, on its way to one of the most ecologically significant springs on Earth. Wakulla Spring is a first magnitude spring, meaning it produces an extraordinary volume of water. It is one of the largest of its kind on the planet. It is also a place where the health of the underground system becomes visible at the surface. And here is what makes that significant. Wakulla Spring is already on Florida's impaired waters list. Its water quality is already compromised. It was struggling before Lake Jackson sent a single gallon its way. Now it is receiving the full contents of a 4,000-acre lake, delivered underground, on a schedule that no surface engineer controls. Dr. McGlynn chairs the Wakulla Springs Alliance and has studied this system for decades. He has been direct about what the current situation requires. Lake Jackson does not recover from half-inch showers. Those evaporate before the next storm arrives. What the basin needs to maintain water above Porter Sink is consistent rainfall in the range of 3 to 6 inches at a time. The National Weather Service forecast of 1 to 3 inches from a stalled cold front is welcome. It is also, in his own words, almost certainly not enough to keep the sinkhole basin underwater. The water is still moving south. The dye study proved the connection. The spring is already stressed, and the system carrying Lake Jackson underground is the same system that supplies drinking water to nearly 400,000 people in the Tallahassee metro area. But the most alarming part of this story is not what is happening right now. It is how often Lake Jackson has started draining in recent years, and why the time between each dry down keeps getting shorter. For most of the last 2 centuries, Lake Jackson disappearing was not a catastrophe. It was a cycle, a predictable, generational rhythm that the land and the people around it had learned to expect. The native Muskogee people knew it well enough to name the lake for it. They called it Oki-Hipki, disappearing waters, not a warning, a description, something that simply happened, the way seasons change and rivers flood, part of the natural order of this particular place. The documented drain record stretches back to 1829, then 1907, then 1932, then 1957, then 1982. 5 events across 153 years. An average of roughly 1 dry down per generation. Families could live their entire lives on the banks of Lake Jackson and never see the bottom. Their children might not either. It was the kind of event grandparents warned grandchildren about, and grandchildren half believed. Then, something changed. Since the late 1990s, the lake has drained partially or fully in 1999, then again in 2001, then 2006, then 2012, then 2021, and now 2025. 6 events in 26 years. The interval that once stretched across 2 decades has collapsed into a handful of years. What used to happen once in a lifetime is now happening repeatedly, within a single generation, and with no sign of slowing down. That shift alone would be alarming. But the 2025 drain is not happening in normal conditions. It is landing on top of the worst drought in Tallahassee's recorded history, turning a geological cycle into a full-scale crisis. In February 2025, the Northwest Florida Water Management District issued a water shortage warning order. It was only the 3rd time in the district's entire 26-year history. The previous 2 were issued in 2002 and 2007. Both of those years fall inside the same window when the lake's drain cycle began accelerating. This time, the shortage is not limited to one district. All 5 Florida water management districts are simultaneously under shortage warnings. Not one corner of the state, all of them. Florida is running a water deficit from the Panhandle to the Keys at the exact same moment that one of its largest lakes is draining through a hole in its own floor. Lake Jackson did not simply disappear, it was set up to disappear. The longest dry stretch in Tallahassee's recorded history fell on a closed basin that already had a drain sitting in its floor, inside a state whose underground water reserves are already being pulled hard from every direction at once. The lake is gone, and the consequences do not stop at the shoreline. They begin there and spread outward, touching every community, every boat ramp, and every creature that called it home. At Falk Drive Landing, the boat ramp ends in mud. There is no water to launch into. There are no boats to launch. The dock that once reached out over the surface now hangs above cracked, dry sediment, pointing at nothing. The parking lot that once filled on weekends sits empty. Local anglers who spent years tracking waterfowl across open water are now walking the same shoreline, tracking shorebirds picking through exposed lake bed. The birds are still there. The water is not. Below the surface, or where the surface used to be, the fish populations are under pressure that no recreational catch limit can address. Bluegill, largemouth bass, and gar have compressed into the few remaining deeper pools concentrated in 2 areas, Church Cove and McInnes Arm. As the water retreats further, the competition for shrinking habitat becomes more intense. More fish in less water, less oxygen, less room. Chris Paxton, a biologist with the Florida Fish and Wildlife Conservation Commission's Division of Freshwater Fisheries Management, has acknowledged what the long-term picture looks like. When the lake eventually refills, the ecosystem will benefit. New sediment, renewed vegetation, a reset that healthy karst lakes have used to their advantage for centuries. But that reassurance does not address what is being lost right now, or how long it will take populations to rebuild after the water comes back. The wildlife disruption extends beyond the water itself. A bobcat was photographed crossing what used to be a functioning boat ramp. Cypress trees that stood in the shallows for decades are now standing in dry air, their trunks exposed 10 feet up, ringed by a pale band of bare bark where the water used to reach. That ring is not decorative. It is a record of absence. 12 miles to the south, the same story is unfolding at Cascade Lake near Tallahassee International Airport. Water levels have dropped so dramatically that cypress trunks once fully submerged now stand exposed for 10 feet above the current ground, their pale water lines visible from the road. One lake draining is an event. Two lakes receding simultaneously is a pattern. For the homeowners who built their lives along Lake Jackson's banks, this is not a geological curiosity. It is their property, their water access, their mornings on the water, and their weekends on the dock. All of it sitting on dry ground with no timeline for recovery. The lake that an entire community built itself around is gone. And the question that nobody living on its edge can fully answer is the same one that scientists are asking about the system underneath. When does it come back? And what condition will it be in when it does? The Florida Aquifer is not a single pool sitting underground waiting to be tapped. It is a vast, interconnected network of limestone chambers, tunnels, and passages that stretches across the entire state. It has no clear boundary, it has no single entry point, and nearly every person, farm, and city in Florida depends on it. For the Tallahassee metro area, the aquifer is not a backup resource. It is the resource. Nearly 400,000 people draw their drinking water from the same underground system that Lake Jackson is currently draining into. The same system that feeds Wakulla Spring. The same system that every city, every farm, and every household in the region is pumping harder right now because drought has eliminated every other source. Think about that pressure from both sides at once. On one side, demand is up. The worst drought in Tallahassee's recorded history has dried up surface water supplies across the region, pushing more withdrawal from the aquifer than it would see under normal conditions. On the other side, natural recharge is down. Rain that normally seeps through the ground and replenishes the system is not falling. And now, Lake Jackson is adding 12 billion gallons of lake water into that same overstressed system at a rate no one controls. Wakulla Spring sits at the receiving end of all of it. Already listed on Florida's impaired waters list before this drain cycle began, the spring is now absorbing the full contents of a 4,000-acre lake delivered underground over months. What the Trace or Die study proved is that Lake Jackson and Wakulla Spring are not separate systems that happen to be near each other. They are directly connected. What enters one affects the other. What stresses one stresses both. And the stress does not end at the spring. Florida already leads the entire United States in sinkhole activity. The same process of limestone dissolution that carved Porter Sink, built the aquifer tunnels, and sculpted Wakulla Spring also opened sinkholes beneath roads, homes, and neighborhoods with no warning. The system that makes Florida's water landscape possible is the same system that makes its ground unstable. Florida Geological Survey data frames the central question that no official has answered publicly. If a lake that drained once every 20 years is now draining every few years, what does that say about the stability of everything else sitting on top of this same aquifer? The sinkholes, the springs, the pipes, the subdivisions. The drain cycle at Lake Jackson is not happening in isolation. It is happening right now in the most sinkhole-prone state in the country, during its worst recorded drought, above an aquifer already under maximum pressure from every direction at once. The Atlantic hurricane season opens on June 1st. A single tropical system tracking across the Gulf of Mexico at the right angle could dump enough rainfall on Tallahassee to refill Lake Jackson in a matter of days. It has happened before. The lake has always come back. The question is whether it comes back fast enough, and whether the sediment plug at Porter Sink seals before the water returns. Porter Sink does not stay open forever. Harley Means and the Florida Geological Survey are clear on this point. Sediment will eventually replug the opening the same way it has sealed itself after every previous dry down for at least 2 centuries. But the timeline is not predictable. It could happen in weeks. It could take longer. Nobody can say when. Without a hurricane, the outlook is harder. Dr. McGlynn has been direct. The 1 to 3 inches of rain forecast from a stalled cold front is welcome. It is not enough. Lake Jackson needs consistent rainfall events in the range of 3 to 6 inches to maintain water above the sinkhole. Half-inch showers evaporate before the next one arrives. Summer without a significant tropical system means the basin likely stays exposed, with vegetation growing across the bottom and the sinkhole continuing to feed the aquifer below. 3 questions hang over Lake Jackson right now. How long will it stay gone? Why is the cycle accelerating from once per generation to once every few years? And what does it mean for Wakulla Spring, one of the largest springs on Earth, to be receiving the full contents of a Florida lake every few years instead of every few decades? Nobody has answered all 3. The data raises them, but the answers stay open. What is not open is what is happening right now. The water that filled this lake on Thanksgiving morning is still moving. Somewhere beneath the pine flats between Tallahassee and the Gulf Coast, it is traveling south in the dark at less than 1 kilometer a day. Porter Sink is still draining. The aquifer is still rising to meet it. What happened to Lake Jackson is not a mystery. The geology is documented. The cycle is recorded. Scientists can trace the water from the moment it enters Porter Sink to the moment it surfaces at Wakulla Spring, 19 miles away and 35 days later. What is not resolved is why the cycle keeps accelerating. A lake that disappeared once per generation is now disappearing every few years. A water management district that issued its first shortage warning in 2002 is now issuing its third. An aquifer that supplies drinking water to 400,000 people is absorbing a major lake at the same time it is being pumped harder than ever before. These are not separate problems. They are the same problem, showing up in different places at the same time. The questions raised at Lake Jackson reach beyond one basin in North Florida. They reach into every community in this state built above the same dissolved limestone. Every spring already showing declining water quality. Every aquifer being drawn down faster than the rain can replace it. Florida has built an entire civilization on top of a cave system. For most of recorded history, that system was stable enough to support it. The question that Lake Jackson is now forcing into plain view is whether it still is. The water is not gone. It is underground, still moving south. Somewhere in the limestone between Tallahassee and the Gulf, the next drain cycle is already being decided, one dry month at a time.